Okay, let's get to work. As you can see on the board here, I have the first two problems from yesterday's assignment. As I promised in the missive, the letter I sent you this morning, I'll be working on these carefully today. And the homework that I'll photo you in a couple of minutes is the same kind of problems, but I'm going to add a little bit of challenge. There'll be 7 altogether. I'll add two extra problems there. Okay, so we do the first one, and what's different about this? Well, they don't give you the radius, they give you what? The circumference. But you know, and I'll show you again, that c equals 2 pi r. You're supposed to know that from 6th grade, even earlier. So that means that if c equals 2 pi r and c equals 12 pi, then 12 pi equals 2 pi r. And when I divide both sides by 2 pi, again, pi always canceling, cancel. 12 divided by 2 is 6, so that r equals 6. So with that, you're easily able to do the problem. If you like, you can just fill in 6 here. And now the cylinder has a volume of pi r squared, which is 6 in this case, and a height of 8. And to save you the trouble of multiplying here, wasting time, the correct answer would be 288 pi. I received some letters yesterday asking me to go over that one. So it's an extra step. Fair question for 8th graders. I gave you another one for today. Hopefully you can do it, and if you can't, you let me know, and we can continue practicing this kind of thing, at least to a certain extent. So I erased the first one. It was 288 pi, and now we go to the next one, and here we have the slant. We don't have the height. We have the diameter. We don't have the radius. So it's an entirely reasonable question. I drop a perpendicular bisector here, and that makes this 9, and this 9, that's going to be the radius. And now we have a 9, question mark, 15, right triangle. You see the right triangle being formed there. Oh, what's the missing number? The missing number is 12. 8th graders would be expected to do something like that. So make sure you understand it. It's a 9, 12, 15 Pythagorean triple. Well, since the height is 12 now, we have all the data we need to find the problem. And it says v equals 1/3 9 squared times 12. And there you go. It's probably easier to do it this way without a calculator. And then it really turns down to what's 81, because 9 squared is 81. 81 times 4. And you should easily, at your age, your development, come up with 324 pi. If this part you want to use the calculator, fine, as long as you include pi, because it's in terms of pi. Okay, we move along. I'm checking the time. We move along quickly. Erase all the superfluous stuff here. So we have the first answer is 288 pi. The second one is 324 pi. Everything in terms of pi. Easy stuff. And now we turn our attention to number 3. Again, a cone. But this time, what did they give you? They gave you the area. Okay? So in this case, the area is 64 pi. Well, it's a very good idea to notice immediately your perfect squares. They're going to become more and more important as we go along. 64 is a perfect square. Keep that in mind. So if a equals 64 pi, and at the same time a equals pi r squared, which you're responsible for, then it follows instantly that pi r squared equals 64 pi. The pi's cancel. I can do that with mental math now. There's no need to do all that. Taking the square root of r squared, and then the square root of this perfect square, then it turns out that r equals 8. And again, simple problem. Now that I know r equals 8, and they gave me in the problem, I didn't write it here, but it was in the problem, h equals 12, then we're cooking right away. So we have v equals 1/3 pi 8 squared times 12. And just as in the previous problem, the numbers were set up to be very good. 8 squared is 64, as you know over there. And 64 times 4, I took the liberty for you. You should easily be able to come up with 256 pi when you multiply these numbers out. So those were the first three. You might have been confused when you tried to do them, but I've just repeated them in today's assignments. So I would expect everybody to be able to do these now, as long as the numbers are nice, and the numbers so far have been extremely nice. Now we turn our attention to number 4, and again, for today, I gave you another one with a water dispensary. Yes, that makes it a water dispenser, whatever they call it. And this would be the same idea. This would be like the third time. So I have this little can or bucket, depending on the word problem. We'll do a couple of them. And the radius is 2 units, and the height is 3 units. It's just set up to make sure that you get the idea. And somehow we're trying to fill up this huge cone-like structure with water or whatever liquid we can think of. So the question would be, how many cups does it take to fill this to the brim? And of course we need data for this. We decided that D equals 12. And I warned the class, you have to watch that. They can go back and forth. And the height here is 12. So again, it would just be a ratio problem. We'd work out the ratios here. I'll do it on the lower part of the board, going left to right. And we'll put the bigger guy on the top and the smaller guy on the bottom, so we can figure out how many cups or buckets or cans would fill up this monster object here. So we do the math on the top. You got to remember that R equals 6. Failure to do that, and you come up with double the answer. And right away, we put the cone on the top, and the cone is 1/3 pi, and there we go, 6 squared times 12, divided by the can, the smaller volume, which is pi, nice little easy number, 2 squared times 3. So there we go again, and you're expected to work through these numbers. At your age, you're expected to have a feeling enough for numbers to be able to come up with what I do. So to make the lines the same, 3 goes into 12 4 times, and we'll just write out the numbers now. The top says pi times 6 times 6 times 4. The bottom says pi times 4. I squared the 2 because I'm looking ahead, times 3. Pi cancels, 4 cancels, and you can go about it any way you like. I guess this is the easiest way, and you get what? A 12-to-1 ratio. That means 12 of these will completely fill up this object over here. Soon, like I said, we'll turn these into real-world problems with feet and inches and things of that nature using our calculator. Okay, so now we turn our attention to the last one. And again, today I gave you one just like it. You can always pause the video and go back and look at what I'm doing. Trying to avoid blocking the whiteboard here. And here the problem we have is that we have this cone, the word problem says, and it tells you that R is 3 and H is 8. And then it tells you that R is doubled and H is decreased by 4. So here we go again. R is doubled, so it's much wider, and H is decreased by 4. So 8 minus 4 is 4. There's your new height. Double R, and the new radius is 6. So they want to know what the ratio between the new and the original was. So I'll put the new on the top and the original on the bottom. But you kids should think about that. It's not necessary that I do that. I don't always have to put the bigger guy on the top or the bottom. And in fact, in this case, I don't even know which one has more volume. I'll have to discover that by doing the math. But I'm deciding to put the bigger guy on the top. So that is 1/3. We'll go over here again, left to right. 1/3 pi. And then we're multiplying 6 squared times 4, and we're dividing that by 1/3 pi. And then we look at the smaller numbers, and that's 3 squared times 8. So people who really think about this see it instantly, right? That if you increase the radius, you increase the volume much more quickly than if you increase the height. And that's something maybe we could talk about down the line. But anyway, let's watch our video carefully here. 1/3 pi, same numbers always cancel. So now let's write out the 6's, write out the 3's, okay? And there we go, 2 to 1, 2 to 1, and 2 to 1. Everybody see what I did? Hold on, there's a mistake here. Excuse me. This was 4, and this was 8. So let's make sure we got everything down here. And then that would be 3, 3. So there's 2 times 2. And there's the 4. And there's the 8. And then we have the number 2 on the bottom here. So the ratio would be, when we work out all the numbers carefully, okay? So double checking here, 2 to 1, 2 to 1, 1 to 2. Hopefully we didn't leave out any numbers. The ratio would be the new is twice the volume of the old one. Okay? So I'm going to leave that here now. I'll go over the video and make sure it's good. And then I'll going to photo you your homework as soon as I get a chance.